area because the 35mm format has 4 sprockets per frame, so there's no way to position the LED time code in between the sprockets like we can on the 16mm views.
Right. So if you looked at the 16mm, you could actually see the sprockets at the top and the bottom of each frame, and those aren't visible in the 35 as you see here.
The camera number is on the lower right hand display of the LED time code, and it's in this case it's camera number 62. So the 35mm format also allows us to put a camera designator number that's fairly often used just to help for viewing purposes and tracking purposes. This again is a 105mm lens and is on the pad perimeter approximately 1,270 feet from the vehicle.
Look at the absolute force that all of this stuff is coming out of there. I've talked earlier in the piece about how much is coming out of the solid rocket boosters, 20,000 pounds combined, and then the SSMEs are losing 3,000 pounds of liquid propellants a second. And that really shows up here when you're looking underneath the launch platform. You can see that all of that stuff doesn't have anywhere to go, which is why it's vectored out on both sides, so it can be sort of safely directed away from the vehicle, so there's no rebounding or sort of backflow, so to speak.
And one thing we haven't had a chance to talk about earlier is how the cameras are triggered. Currently, the camera's all triggered using the POX, or the photo optical control system, which triggers all the cameras on the pad perimeter, on the fixed surface structure, as well as the MLP. And it's quite a sophisticated system to synchronize and trigger all the cameras based on the launch clock.
Yeah, it's undoubtedly a very complex system to have all these cameras operate flawlessly for each launch. They're very important, if not critical, for shuttle launches, and it's an amazing achievement that all the men and women who work on this are able to do it with such a degree of reliability every launch. Another shot here is, as I said, moving around counterclockwise. You see the SSMEs, or the boosters, are just firing, excuse me, and there you see the gup falling back, as we talked about earlier, the umbilical assembly.
This view is using the same 105mm focal length lens that the other two views we just looked at, and again is about 1,200 feet from the vehicles where the camera site is located.
You know, this was a really unusual day because you just mentioned earlier that, you know, not from all views is the lighting going to be as good, but this is about as good as it gets. I mean, each and every one of these camera views is well exposed, both from an engineering and a beauty standpoint. They're all very, very nice shots. And it's why we selected 124 to be the predominant content in this movie. There's the water tower, by the way, in the foreground. It's just about to get engulfed with the exhaust.
This is a Dog 68. It's a 35mm camera, and it's really intended to be a documentary camera. So it's running at 28 frames per second, not really a high-speed camera. So it's almost real-time, a real-time camera view. It's just a really beautiful shot, and because it's a documentary camera, we're able to enlarge the aperture so that the timing block isn't taking up image area, and present it in its widescreen view, and I think it's quite dramatic.
Yeah, from a beauty standpoint, this is probably at the top of my list for favorites. It's just gorgeous quality, fantastic color saturation, and very unusual for shuttle photography to be so beautiful at the same time.
So Echo 55 begins our series of tracking cameras. Echo 55 is mounted on a kineto tracking mount, or KTM, which we commonly refer to it as, and it's located at CS1 about 1,200 feet from the vehicle.
This is a nice shot because you can see there's a bit of a distortion cloud here that we're shooting through, and what that is hydrogen being burned off from the fueling system. They burn off any excess hydrogen to safely combust it. And so that's what we're seeing here, and it's really gorgeous as the vehicle sort of comes out of that and goes into its roll program, clearing the tower. Again, just a fantastically well lit photograph on this day. Some of the white things that you see falling off there are paper covers, which protect some of the order maneuvering system engines. We'll talk about those later. But Kevin, these are all manually operated, right? I mean, there are human beings behind the scenes doing this tracking now.
Yes, this KTM, or the kinetic tracking mount, has about 4 cameras that are mounted on it. And this particular camera, Echo 55, is one of a pair of cameras and is intended to look at the top half of the vehicle, while the other camera is intended to look at the bottom portion of the vehicle.
Right, and we'll see that in the next shot. We'll have one of the views from the bottom of the stack on the next one. In fact, our intent is to have in the deleted scenes on this disc a set of camera pair views sort of pieced together so you can see them simultaneously. So look for that in the extra features. This is fantastic. Now they're completely done with their roll program and sort of on their way.
Yeah, the intent of that camera shot is only for the first 1,200 feet of the ascent. Is really the intention of that view, and that takes about 18 to 20 seconds, I believe. Okay.
Now this is camera 52, and this, of course, is at the bottom of the stack now. So it's a little different view, and but part of a camera pair again.
Right. This camera is, as you said, is 52, and this is located on camera site 2. And is about the same distance, 1,200 feet, 1,270 feet from the vehicle.
Nice shot of the SSMEs there. It always amazes me how transparent the exhaust coming out of the SSMEs is.
Now this kinetic tracking mount is controlled by an operator, manually controlled by an operator who's sitting in the LCC on the second floor below the firing room. And the person, he or she, is using a trackball to track the vehicle, and it's pretty tricky because they're just looking at a little video monitor, and the vehicle is moving much faster in real time than we're seeing. We're seeing it at 1/5 the speed in this particular case of what it is in real time. This kinetic tracking mount also has HDTV cameras that are mounted that are used for what we'll call quick look, what's called quick look. To look at these views in real time and then in near real time, when they start the image analysis. This is done while the film is getting processed and transferred.
That was a fantastic shot, seeing the sun go right in between the two plumes, and in fact it gives you an idea how bright these plumes are to the naked eye, because the sun, as it passed through there, wasn't much brighter than the plumes that you saw. Wonderful shot showing the column of fire that the vehicle rises on, and it really contrasts nicely with the blue. Again, highlighting why STS-124 was really the correct mission to sort of springboard off of, to show all the beautiful film.